Hello everyone, Peter here, Piotr Fisner. Guys, I'm not wearing my t-shirt today. I felt like maybe it's a time for a red me, so I've decided to go red today. Who knows, maybe I'm prettier or maybe the opposite. But anyways, long story short, that's a power supply. It's a UE50MU6100K. Okay, we had it ordered for about £12 and it came. Yay, happy days, came. Here's a sticker. I've got two other recordings before this, but those were irrelevant. This turns out to get this fuse blown. So this fuse here actually is a fuse from my customer's TV. Okay, I've contacted through eBay that company and I've desoldered, this fuse. So here is a new fuse, but it's turning out that this fuse is blown when I'm plugging this in. Not only that, this fuse in the plug is blown as well. So I've made a test and I found out that the bridge rectifier, which is nasty here looking because it's quite difficult to remove, is when it's in, it's showing on the meter 1285 about, or 1278 or something like that millivolt drop in the diode test. So I said to myself, okay, so let me get the second power supply, which I know has a good bridge rectifier, and the drop over there is open line, so that's mean okay, no problems, which we will see next. So I will replace these two and see maybe if that power supply will boot up, maybe, and if so, customer wouldn't have to wait on another power supply and so on. So that's what I did till now. I didn't want to show you all of that because I knew that that it will have no value. So we've got a power supply. We've got this diode here. Okay, that's a bridge rectifier here. And let me adjust the ISO because it's okay. It's slightly better though. ISO 200. Let's leave it on that. And now what's happening in between, in the AC here, we had a short. Okay, so let's get a meter because this is the second power supply and it's fine. So I want you to see it so that you will understand where I'm coming from exactly. So that's a diode mode test here. Let's power it on. Let's see that you barely can see. It is what it is. So let me adjust it a bit. Okay, so now it's working. So you can see on the monitor. Then when I'm putting these two, it's raising. So some capacitor is loading up, and it's beyond. Yeah, so it's fine. And here is none. Okay, so that's a regular stuff. And when I'm touching these two probes, it's beeping, so I know that my meter is fine. Whereas if I'll take this, which came from that company, where do we have this? Here. Okay, if I'll put that bridge rectifier the way it was, so that would be this side. Okay, that would be this side. Oh, come on, you cheeky monkey. I can only insert it. Then when I was taking my probes, now you don't wanna, yeah? Oh, it is what it is. But it was showing here a drop, or you can see 1270 or something, yeah? So that what was 1269 even, okay? When I'm picking up this and putting it aside, when I'm trying to test it, it's nothing. Okay, when I'm going along and trying to catch pin on this side, and here is a diode, so here you see it's nothing, yes? So that's why I knew that when I desoldered it, that it could be a problem with this bridge rectifier. So let's put it aside and let's try to get rid of that one. But I'm telling you, this is a pain. I love soldering, but this is a pain. So although I like soldering, really, I really love it, I hate this. And you'll understand why. First we need to remove that screw, okay? And after removing that screw, which is okay, that's not a problem, yes, that's the least of our worries. Now we've got two bits here, and these two bits have an issue because they are not only inserted, they are banded. So you have to remove the solder from it, and then you have to just literally bend them with something, yes, like pliers or whatever. So if I'm trying only do this, I'll show you. I don't have to, but it's slightly easier with a bit of flux. I'll open the window as well because it will give us, well, give me nasty fumes. I should build some extraction, but oh well, or order some extraction, but oh well. What I'm doing only is cleaning up. Now I'm using this, okay, to remove it. You can use wick as well, but in the first phase I prefer to get the most with this, so then I can use a wick if I have to, yes, because that's not SMD component, that's just a bridge rectifier. So let's do it, okay? So guys, if you get bored because you do see me working here with it, maybe you can hit that like button, because I got least likes, you know. It's not a big deal for use, but at least I know somebody's really watching them, and it's not only numbers showing that somebody is watching. Okay, so I see that it doesn't do a decent progress. Before I've done the opposite way. I've done the radiator first, and then I did the bridge rectifier. Now I'm trying the opposite way. I mean, I will try not to remove it because I went through so much hassle yesterday to deal with it that I decided maybe I won't remove that radiator. Maybe I will just leave it. Maybe I will be able to do it. Okay, it's taking some solder, it doesn't wow in me here. I'm not super excited with what's happening. It's really nasty, guys. Removing it, it's no fun. Completely no fun. Okay, so we've got it sort of done. It's not end, it's not the end, believe or not, it's not the end. Come on, cut yourself, or I'll cut yourself. Okay, now the problem only is that this here, I don't know if you can, no, you can't zoom in more than you want. That's fine. But when I'm lifting it up, I'll look through this to see what have loosened up, what didn't, and I'll tell you. Okay, so first one did lose up because it's moving. This one didn't. This one it still holds. This one holds, and this one holds. So only one has loosened up. You see how much hassle I had to go through to do only this bit. But it is what it is. You know, even if I would increase the temp to 60 watts to the max temp, I would like to pick it up, but okay, you know what, let's do it the right way. Let's do it because I see that I will be struggling without removing it from this. So this will be a procedure which will take us a few minutes. I'm doing it so that you will know if you would face it, yes? You will know how to do it. And don't feel bad about yourself that it's taking you some time and you can't do it. Don't beat yourself, because that's the whole procedure, and really you might be doing everything right, but it is what it is here, and no point to beat yourself over stupid thing. Where's the wick? Let's correct it with a wick. Okay, this is actually quite clear, and I'm quite happy with this one. I'm quite happy with this one as well, to be true. This one is quite... Okay, this I'll be struggling, so I will heat it up as the last one. Hope you can see. Trying to do it from this side. Okay, and last is here. Now my method to it is just to leave this on, because my one has to be on. Now I know that these two will be fine, but I need to twist it, okay? Why you're not holding me there? Okay. Hope you see focus well. You see, I need to twist it and make it like that, otherwise it won't just work. Okay, now I can use something underneath to take it away. Okay, this went smoothly, no problem. And now the other side, I'll need to use a lift, like leverage, okay, from the bottom, and heat it up. Just heat it up. Okay. Oh. 1, 2. Ah, sorry. Okay. What am I doing? Oh, I'm doing the wrong one. Yay, now I'm doing the right one. I was saying to myself, why it's not working the way I wanted. So I'm just using leverage at the bottom, trying to heat up. I could increase the temp now, or add more flux, that would help as well. Come on. Okay, guys, I'll add some flux and add. Okay, and now with this leverage at the bottom, hopefully this flux will help us heat it up. If no, I'll have to add. Oh yeah, you see, if there was no flux, there was no connection of the heat and we couldn't get it out. But because we've added that heat, then automatically what have happened was that it helped us. Now, because I'm struggling on the other side, and I was struggling, now I know how to approach it, okay? So my way was wrong, because I was constantly trying to do it. I'll only clean this, yes? Tip. Because I was trying constantly to heat it up only from one side, I was struggling. But now I'm smarter, because I went okay, now you see I'm lifting it up, and if it doesn't want to go, I can heat up the feet of this and that will go. You can increase the temp if you don't have 60 watt, you can increase here on the max. If you get 60 watts, you don't have to use max temp. Oh, that's loosen up, good. Now the next one as well goes up, and just leave it. Do it gradual, don't do it, you know, all at once, because you can make more harm than it's worth. It's nasty, guys. Now I know how it's built, so if you still struggle like me, just use a bit of flux, okay? Just pour some flux. I'll pour even to the second one as well. That will make the heat transfer quicker. When you see smoke, that's mean good. You've done a good job. Okay? Just leave it be. If it doesn't wanna, just take it to the second side. Try to catch the focus. And let's try to heat it up. Okay, and we need to try to heat up both simultaneously if possible, but we don't have hot air. I was trying with hot air, and believe me, it's worse than this. That's how bad it was yesterday. Okay, you see, so it's super hot, that's why you don't want it to. Okay, so this feed has let go, this feed went really far, so now we need to do the third one. I know you might not see everything, but gradually, if you're doing it, yes, you'll be okay. Whoa, you see, we are okay. Now guys, we can solder to the other board, so we know that this one has this sticker, so we know that this with a sticker is the one originally from this TV. You can put it aside. Believe me, I want to finish it today if possible, because I've spent so much time that it would be no value for the customer. Okay, it's super hot when I'm touching it. It's super hot. Okay, so let's put this here. I'll know that this can be nasty because that's a shelf of my faulty components. And let's put it in. Let's try to put it in, because I know we can struggle as well. Okay, actually I didn't struggle at all. We got all the pins done. So you see, this process already took me 20 minutes. Yes, I was explaining. Yes, I was not super quick with it, but that's already, it's 20 minutes, just the extraction part. Yes, it is what it is, and we can't say we did something wrong here. We did great, actually. Now let's put this radiator and try to fit the screw as well, so that we know the alignment will be okay. Ooh, that's a lot of that metal went out and it's stuck here. I don't know if I'm able to put that through. Might remove that metal and then put it through. Oh, actually no, it went in. That's okay, that's fine. Okay guys, so we've got it now. We should try to, oh, actually it's aligned. Surprise, surprise, something went well. Let's get this screw in. There was the space, so I didn't add more. Where are you? Ah, you are here. I'll order these diodes, so I will try to. Why this is not going well? Okay, it's going. So I will try to fix the other power supply as well, but when parts are coming from China, it's taking, like ages. So that's why I didn't want this customer to wait ages. And that's why I said, that it would be better if we could just, it's quite dark, yeah, I would say. Let's do ISO 400, maybe 800. Oh no, it's better 400. So I said, well, maybe let's just not go nuts, then don't order stuff from China. If we would have to, we would, but we can do something like here, use cheap power supply from eBay. A lot of amps here, so we can't neglect it. It has to be soldered well. Because it's too many amps to, just do a crappy job. Okay, so we've got this sorted. And now we need this heat stuff. Oh, I didn't use flax, actually, sorry, am I wrong? See, the good thing about flax is that even if it's quite dear, you don't use it tons, so it lasts you for a long time. So that's why don't try to save up on a cheap flux. Don't be an Ebenezer Scrooge, because it will kick your butt for doing it. Okay, I won't be cleaning it. Okay, I will be just, it's actually quite warm, but it's not hot. Let's see on the meter if we've got short this time on the diode mode and on this here as we had. Oh no, we have. So I was wrong about the diode. So something else is shorting, or I've soldered the wrong diode. Either or. But I couldn't solder wrong diode. So in that case, guys, I've just wasted the time. At least this time it went quickly, and I've done it within 26 minutes. And I'm just wondering what else can make that short, because that short is still here. 1218, 1219, it's growing, but probably it's a heat stuff. So I can't plug in the power, because when I'm plugging the power, it automatically shutting the fuse off. So, and it's growing, so the heat is giving the resistance. But even though I will make it cold, it shouldn't matter. It should be 0 here, or 1, like it is. I feel stupid, guys, right now, because I knew on the second power supply when I plugged that diode, and that was fine. I mean, on the original diode it was fine. Whereas here, I've placed this, which was good, and I see that I've got the same problem. And I'm wondering what I did wrong, or what I don't understand. Yeah, it's growing when the temp is dropping, so it's looking like what this chipset is receiving too much heat when I'm desoldering it, and then yeah, this has flat legs, so I know that came out from this mainboard, because I was bending it. And let me disconnect my iron. Okay, now if you know, this cutted side is plus, these two are the plus and minus, and this is not shorted now, this is okay. So here, yes, and the opposite way should, yes, 461, so it's fine. Here, okay, good, and here, so it's fine. Okay, so that's central bit is usually the AC coming in, and here is plus on this cutted side and minus on this not cutted side. Yes, so this bridge is fine. Then we can solder it back, by the way. But in that case, I've wasted the time, and I don't know what's causing that, and that's a problem. Oh, it's nasty here. super nasty. Yes, it's a solder all the way through. So I'll be struggling, so it's no point. So I've got two faulty power supplies and I don't know what's causing the short. I'll need to rethink this and make further diagnosis, and then I think I'll do the part 2 of this, because I can't get my head around it. I thought I know what I'm doing, and I thought I found the problem, and I found you know, everything about it, but it's turning out that I was wrong. So I need to go all the way along, and I'm not cutting these videos, so it would take you too long, you know. I know for sure that this shouldn't show 1254, okay? This should show just 1. Now this is growing, yes? So that's mean it's growing because the temp is going down on the bridge rectifier here, on this. So that it does influence, but that should go down to 0, and it won't go because it's nearly cold, nearly the room temp, especially that at this second side, you know, it's cold, completely cold. So I would say that won't raise too much. That will raise to this 1270 or something. Okay, that should be diode. So if on this side we've got a beep, here we've got drop, and what if we will do it the opposite way? Beep and 1, 1. Okay, that's okay as well. So on this side, yes, on this side diodes are fine. So it's not because of those diodes. Oh, why there's... Okay, now it's connecting. Okay, so these diodes are fine. They are only pushing through current through one direction. So from this to this, which is fine, anode and cathode. Anode to cathode, that's okay, because that's the direction which goes from here to this, here, and goes to this, and then it's going to this chipset. Okay, so would the chipset have anything to do in that case? Don't know what the chipset is. I know one thing. When I've removed it, there was no short on this, and I did check only this road to here, okay, because it's actually simple. When the current is coming in, I'll show you on this, okay. When the current comes in, it goes through the fuse here, because that's a neutral, that's live, okay? So now goes through this fuse. Now after the fuse, it's going through the varistor here, okay? And there are a few varistors, but like here, but it doesn't matter. Here, goes through this varistor. So if the varistor is shorted, of course we would have a short, yes? Completely to the ground. like we have those two here just on previous episodes. Now what's happening after this one, it goes through the coil. Here there is a coil, I'll show you the coil. Okay, that's the coil. So it goes through this coil. So you have this inlet, fuse, yes, and it goes through the coil. That's how it goes. Yes, that's the varistor I was talking about. Now after this, where are we? Okay, you can see it, that's fine. After this, it goes further to this point, okay, and here is here this pin. What is that's the capacitor. Okay, so that's irrelevant because capacitor will go to the ground. I'd say that's capacitor here, and behind the capacitor what do we have? We've got a coil. Okay, so that's relevant. So there are two coils, smaller one on this side and bigger one on this side. Yes, so that's the bigger one which I've shown was here. Now that goes, yes, that goes, look, you see this? That goes from the coil to bridge rectifier, okay? And that's one side of the coil. The second side of the coil is here, that's AC and AC drawn on it. So that's that's inlet for the AC. So if this goes through the coil goes to here, and then we've got this coil goes up to here through varistors. I think there are two varistors, and then goes to here. Here is the second coil, I think, or something else. What is over there? Yes, that's another coil. So here is one coil, and here is the second coil. And now, as you see from this coil, it's cut it here, and it goes to here, yes, and then goes through the varistor here, and through the small coil, yes, through the small coil goes, yes, and they are not. So this goes to this coil, then the current goes to here, and then this is the fuse, okay, and that's everything. There's no more components, so I've checked all the components. So again, inlet through fuse, goes through varistor to the coil, send it through two varistors to the second coil, and then that goes through to the bridge rectifier, and then there is a magic happening, which is rectification here, additional rectification, and this rectification goes through this, through some coil again, or diode or something, I don't know what it is, but it's something here, and that goes through another like this, and that goes to this chipset, and this chipset is a driver, okay, so that drives this. So now the question is, if I can remove this, how many legs? 1, 2, 3, 4, 5, 6, 7, 8 legs, so that's 16, SIP 16. If I'll remove that SIP 16, this controller, will I remove this short? Because if bridge rectifier was okay, and I've checked that, I know that up till here, up till the mains, I've got everything okay. Whereas behind it, yes, behind it, plus I'm not interested as much as I need to first check what's before, and before it's an inlet of the AC on those two pins, and my short was on the inlet side, yes, because if this would be on the outlet side, then maybe it would just cut off, and then wouldn't short my ground. But it's quite likely that the chipset, the driver chipset, is faulty, and if that's the case, I need to check on my power supply if the chipset is fine and replace it. But it's a bit of ungluing, and the video is for 40 minutes. So guys, let's call it a day, because that's 40 minutes. I know that I don't want to do long videos. So guys, that's a part one. We understand the problem. On the mains we've got a short to the ground. Drop on the diode mode is 1280, 1270, yes, depending on the temp of the bridge rectifier, of course. And what's happening is that although we try to replace the bridge rectifier, we've seen that it's actually not the case, and we see that there was no short when we removed that. So I was happy to place another one. I've placed that another one, but it turns out that actually it's still the problem, and I don't see any other components which would cause that, because those coils are primary and secondary, yes, so they are not connected, they are not touching each other. And when you take the meter, you see that they are not touching. The coil is an inductor, yes, sort of thing. So it's induction of one causing power on the second one, and that's how it's working, yes. Now they are separated from each other, yes, like enameled copper wire. Now what's happening is we go further and we see that controller, okay. So I will blindly, just from my expertise in the previous years, I will just blindly remove that controller in the next episode, and we will see if that will remove the problem, yes. Because if that will remove the problem, then that's mean, you know, we might be lucky, fingers crossed, to put from the original power supply from this TV again this SIP 16, yes, chip, and fingers crossed, you know, maybe it will work, maybe. But if no, I will have to look further for another component which can short it, yes. But I don't want to waste time. If I would, you know, if I would just go in every component and the solder it, that would be stupid, because if you don't see a fault, you know which things can short, you know which things shouldn't short, yes. And if you know that, if you've got this knowledge from electronics, you should have a rough idea what to and how to test, yes. But for today, we've got everything. We've got 42 minutes recording, and that's why I don't want to do it for hours and hours. If you are interested in seeing what I came up with, you'll have to wait. I'll be recording second and posting second recording after this one, because I want to finish it today if possible. Thank you guys. If possible, let's save them all. And those who didn't, please like. That will show me that at least somebody is really watching it, and those numbers are not just raising up, yes? Thank you guys, and see you in the next video. Bye bye.